Could the U.S. government really be concealing a top-secret UFO program? Several senators say the answer is yes.
Do you become a multi-planet civilization or not? And if you don't, it's simply a matter of time before something happens on your planet.
35 years, 13 billion miles journey. It began in 1972 when the project started, July of 1972. 2 spacecraft in 1977 for Jupiter, Saturn, Uranus, and Neptune.
Voyager 1 has just picked up something horrifying, signals aimed directly at Earth from deep space. This alarm is real and has urgently alerted military officials around the world. Now, with these signals originating billions of miles away, we are forced to consider, could someone be trying to reach us? Let us reveal these alien messages that have put high-ranking officials on maximum alert. Humanity's quest for interstellar existence. Since 2018, the scientific world has been perplexed by a strange signal that arrives every 22 minutes without any clear explanation. Some suggest that these signals could come from a civilization that we have not yet identified. The discovery of this unusual radio signal was made not by a veteran astronomer, but by Tyrone O'Doherty, an undergraduate student at Curtin University in Australia. Tyrone was engaged in a routine project, analyzing old data from the sky, looking for unusual blinking radio signals. His diligent work paid off when he detected a signal from 28 years ago that sent radio waves toward Earth, similar to a lighthouse. Excited by his find, Tyrone shared the discovery with his mentor, Natasha Hurley Walker. An experienced radio astronomer, Natasha took a deep dive into the analysis with her team. They worked hard, sifting through various frequency data, but were stumped at first. When they were about to give up, Natasha discovered a pattern. The signal repeated every 18 minutes. This discovery was a significant moment, but as they prepared for a more in-depth investigation, the signal disappeared after just 3 months, leaving them filled with unanswered questions. Driven by curiosity, Natasha revisited the old radio data. Their hard work uncovered a startling fact. These signals had been quietly reaching Earth for 35 years. In 1988, telescopes in India and America had detected these signals, but they were buried under a flood of other data at the time. This revelation excited the team. They could now start calculating the distance of this mysterious object from Earth. They determined it was an incredible 15,000 light-years away. Yet, figuring out what this object was proved to be challenging. They carefully compared it against every known type of radio-emitting celestial body, but nothing fit. In the giant expanse of space, scientists have encountered a perplexing signal that seems to defy the usual explanations offered by known cosmic phenomena. The excitement about potentially understanding more about the universe, or even contacting extraterrestrial beings, must be tempered with caution due to the lack of solid evidence supporting such extraordinary claims. What appears to be an interaction with distant civilizations might merely be an unusual natural occurrence. Among the theories being considered, the pulsar theory initially seemed promising. Pulsars are dense remnants of enormous stars that have exploded in spectacular supernovae and collapsed into neutron stars. These neutron stars emit beams of energy due to their strong magnetic fields, acting as cosmic lighthouses across the galaxy. However, the characteristics of the observed signals don't fully align with typical pulsar behavior. Pulsars usually weaken over time and eventually stop emitting, but the signal in question continues to emit with undiminished strength. Magnetars, a variant of pulsars with even stronger magnetic fields, offer another potential explanation. These stars could theoretically account for the persistent intensity of the signal, but they also present a mismatch. Magnetars are expected to emit X-rays alongside radio waves, yet the riddle signal shows only the latter. This inconsistency complicates the fit into the magnetar model. The dwarf pulsar theory introduces another layer to the puzzle. This theory proposes that a smaller star, known as a white dwarf, could mimic pulsar-like characteristics under certain conditions. Typically, white dwarfs lack the magnetic potency to produce significant light shows. However, if such a star acquires substantial mass, nearing the size of the Sun, it could begin to pulsate with a newfound intensity. The signal's periodicity, flashing every 22 minutes, closely matches this modified behavior, making it a plausible explanation, albeit one that stretches the imagination. Additionally, the phenomenon of fast radio bursts could provide insights into the nature of the signal. FRBs are brief yet powerful bursts of energy that outshine entire galaxies momentarily. These bursts could serve as a comparative framework for understanding the slower, less intense signal being studied. Understanding these FRBs is a significant challenge for scientists who are trying to determine their origins. The bursts could be originating from various cosmic events, such as stars colliding, galaxies merging, or from the less common white dwarfs. These bursts travel through space and collect data from the cosmic environments they encounter, like clouds of interstellar gas. The idea that FRBs are messages from extraterrestrial beings seems unlikely due to the frequent occurrence of these bursts and the massive amount of energy they would require, surpassing the energy of entire galaxies. On another front, Voyager 1, after more than 46 years in space, continues to send unusual signals back to Earth, confusing NASA scientists. Impressively, this spacecraft is still functioning well, despite being far beyond its expected lifespan. Launched in 1977, Voyager 1 was initially tasked with exploring Jupiter and Saturn, with a mission expected to last about 5 years, yet it has far surpassed that, still actively sending back data. Voyager 1 has sent back beautiful and detailed images of Jupiter and Saturn, unveiling their grand landscapes and active atmospheres. These images, available on NASA's website, have fascinated people worldwide, offering a closer look at these distant gas giants. Beyond visual discoveries, Voyager 1 has significantly contributed to our understanding of the outer planets. It discovered new moons orbiting Jupiter and uncovered a previously unknown ring system around the planet, enhancing our knowledge of these large celestial bodies. The spacecraft confirmed that Jupiter's famous red spot is actually a massive, extremely fast storm, which helped scientists better understand the planet's complex weather systems. Voyager 1's path into deep space reveals surprising new discoveries, a speck of significance in space. Voyager 1, located at the farthest reaches of our solar system, faces the frontier where solar winds meet the gas of outer space. This probe's mission is to gather vital data in this hostile area, helping us understand the interactions beyond our solar system. This information reveals the intricate dynamics between stars and the empty space surrounding them. From over 4 billion miles away, Voyager has sent back 60 photos, assembled into a mosaic that provides a fresh view of our solar system. The iconic pale blue dot image is particularly striking, showing Earth as a tiny, barely visible dot amidst the vast universe. This image reminds us of our planet's insignificance, yet underscores its importance and vulnerability. Beyond taking pictures, Voyager 1 carries a significant message with the Voyager Golden Records, intended for any extraterrestrial beings that might find them. These records are modern time capsules containing sounds, images, and greetings in 55 languages, including extinct ones. They showcase Earth's cultural richness, with music from Beethoven to blues by Louis Armstrong and natural sounds from our planet. The Golden Records also include speeches by historical figures like Kurt Waldheim and Jimmy Carter, aiming to represent Earth's diverse cultures and environments. To help extraterrestrial finders understand these records, they come with a needle for playing the sounds, a visual guide for translating them, and a pulsar map to locate Earth. Today, Voyager 1 holds the title of the most distant man-made object from Earth. It is positioned 4 astronomical units away, which equates to an extraordinary distance of approximately 14.2 billion miles. This not only marks a new milestone, surpassing the previous record set by Pioneer 10 in 1998, but it also highlights the impressive speed at which Voyager 1 travels, about 35,000 miles per hour. This velocity dwarfs that of the fastest vehicles on Earth and underlines the extraordinary capabilities of this spacecraft. Voyager 1 is on a long path that will take around 300 years to reach the Oort cloud's edge. Beyond that, in 30,000 years, it will finally leave our solar system. Its mission may continue as it potentially approaches a red dwarf star named GLE 445, located in the Giraffe constellation. If it stays on course, it could wander the Milky Way galaxy for 10,000 more years as a space traveler. Voyager 1 experienced an unexpected technical issue with its attitude articulation and control system. This system is crucial for maintaining its direction and connection with Earth. The problem caused the spacecraft's trajectory data to mismatch its actual path, akin to getting slightly lost in the enormity of space. Despite this hiccup, the spacecraft's communication with Earth remained strong and uninterrupted. Suzanne Dodd, who oversees the management of Voyager 1 and its twin Voyager 2, is actively working to resolve this technical challenge. These spacecrafts are now much older than initially anticipated, and their continued operation offers valuable lessons and hopes for future missions. Both Voyager spacecraft have exceeded their expected lifespans, demonstrating exceptional durability and the effectiveness of human technological design. The NASA team responsible for these spacecraft is committed to solving the recent problem. They are considering various solutions, including software adjustments and possibly activating backup systems to ensure continued operation. The skill of the Voyager team was previously demonstrated in 2017 when they successfully reactivated dormant thrusters to maintain control of Voyager 1. This innovative solution was a testament to their ability to adapt and utilize available resources effectively. More recently, the team managed to correct the AAC issue by identifying and fixing a data routing error and rectified a malfunction caused by a cosmic ray, which had disrupted Voyager's memory system. They restored normal operations by reprogramming the flight data system to bypass the affected memory segment. Freeman Dyson's theories, originating from speculative science fiction, propose using structures called Dyson swarms to collect energy directly from stars. These swarms would consist of numerous small platforms orbiting a star, capturing energy, a concept that Dyson explored in a scientific paper in the 1960s. He suggested that such megastructures could be identified by their unique infrared emissions, distinct from those of natural celestial bodies. Tabby's star, also known by its catalog name KC 8462852, became famous not for signs of alien life, but because it dims in an unusual way. People first thought this dimming might be caused by a gigantic structure built by aliens, but it turned out to be just a cloud of dust blocking our view. Similarly, recent research has looked at other stars that shine strangely bright in infrared light. This could have been a sign of advanced alien technology, but closer inspection suggests simpler explanations, like dust clouds or bits of planets smashing together. Exploring interstellar space uncovers unexpected phenomena. The continuing quest to decode the cosmos. Scientists have noticed that 7 nearby red dwarf stars, all within 900 light-years, are shining with infrared light 60 times brighter than we would expect. This exciting finding could point to huge alien constructions or more natural cosmic events. Farther out, up to 6,500 light-years away, 53 stars are showing similar unusual brightening, which again might be explained by ordinary cosmic activity like planets forming or stars colliding. Researchers are keen to study these stars more closely using high-tech tools like the James Webb Space Telescope. This could help us understand whether we're seeing signs of alien civilizations or just witnessing the normal behavior of stars and planets. The notion that black holes could be gateways to other dimensions captures the imagination, but it's a stretch from our current scientific understanding. For now, black holes remain fascinating for their extreme properties and what they can teach us about the laws of physics. As scientists continue to study these and other cosmic phenomena, every new piece of data helps us better understand the universe, though it often leads to more questions than answers. This ongoing exploration is crucial for slowly unraveling the complexities of space, helping us piece together how stars, planets, and galaxies behave. The vast expanse of the universe and revelations about powerful yet silent forces continued to emerge. These forces, particularly black holes, captivated the scientific community. Following the landmark discovery of Cygnus X1, a renewed zeal for uncovering more such phenomena swept through researchers. It was speculated that the Milky Way might be teeming with black holes, with estimates wildly proposing the existence of up to 100 million within the galaxy. Despite this large number, the task of accurately identifying them was daunting. Black holes are notoriously difficult to detect, blending seamlessly into the cosmic backdrop unless interacting with nearby matter. This elusive nature of black holes made them both a fascinating subject and a formidable challenge for astronomers. Studies suggested that millions of these gravitational giants dotted the Milky Way, making them an undeniable part of the galactic environment. The primary focus of black hole research revolved around their gravity. These cosmic entities exerted such strong gravitational forces that they could pull in and obliterate anything that ventured too close, compressing it into a singularity, an area of infinite density. Simplifying this, one could liken black holes to cosmic vacuum cleaners capable of devouring everything from minuscule space particles to colossal stars. This overwhelming power positioned black holes as both awe-inspiring and fear-inducing subjects of scientific inquiry. Extensive investigations into the nature of black holes revealed some unsettling truths. For instance, anything unfortunate enough to cross into a black hole's event horizon would undergo a drastic transformation, being stretched and compressed in a process astrophysicists whimsically termed spaghettification. This phenomenon would ultimately result in the object being elongated into a thin strand before it was torn apart. Although reminiscent of a scene from a science fiction novel, this was a real and scientifically supported occurrence, albeit one that unfolded over a prolonged and excruciating timeline. Paths into a black hole were strongly discouraged. The closest known black hole was at a safe enough distance to not pose an immediate threat to Earth, but its existence prompted serious consideration of the potential hazards black holes could present. Despite their widespread presence in the galaxy and their potential for cataclysmic events, the actual threat to our solar system remained minimal due to the enormous distances and specific cosmic conditions required for a direct impact. Nevertheless, the immense power and unpredictability of black holes continued to draw significant attention, fueling ongoing research and exploration aimed at uncovering more about these formidable cosmic phenomena. The infinite expanse of space, scientists had recently assembled a composite image that revealed much about the structure of black holes, challenging the common misconception that these celestial phenomena were merely empty voids. Instead, black holes were found to possess multiple layers, each contributing to their complex nature. One must understand its intricate layered makeup to grasp what a black hole entails. The structure of a black hole begins at the event horizon, which serves as the ultimate boundary, the point of no return. Anything that crosses this line, whether it is particles or light, is inevitably pulled towards the center of the black hole, never to escape. This layer effectively conceals the complexities that lie further inside. Deeper within the black hole, past the event horizon, lies the photon sphere. Here, light bends around it, trapped in an endless loop due to the immense gravitational force. This light, unable to escape, contributes to the increasing mass of the black hole. Beyond the photon sphere is the core of the black hole, the singularity. At this juncture, the very fabric of space and time collapses, and matter is compressed into an infinitely dense point. Traditional laws of physics falter here, rendering predictions nearly impossible. The singularity distorts the usual understanding of space and time, making the core of a black hole a place where conventional physics offers little in terms of explanations. This unique and unpredictable nature makes each black hole a subject of intense study, as they exhibit significant variations even among those that share a basic structural framework. These differences not only pose unique challenges, but also provide insights into the fundamental properties of space-time, gravity, and the universe. Studying black holes diverges significantly from the examination of other celestial bodies like stars or planets. Since black holes emit no light or radiation, scientists must employ indirect methods of study. They analyze the radiation emitted by material being sucked into the black hole or the effects on nearby stars and gas clouds to gather data. The universe's hidden forces challenge our understanding, the ancient science of the unreachable. Bill Nye emphasizes the extreme conditions surrounding black holes and the challenges they pose for scientific investigation. Unlike missions that send spacecrafts like NASA's Voyager to explore space, delving into a black hole is not currently possible due to the extreme gravitational forces at play. Any object daring to cross the event horizon would be torn apart and obliterated by the immense gravitational pull, making direct exploration unfeasible with present technology. Consequently, researchers are confined to observing black holes from a safe distance, deducing their properties by studying their effects on surrounding celestial objects. The uniqueness of each black hole adds layers of complexity to these studies, challenging the traditional scientific methods that rely on observable phenomena and predictable laws. The need for new theories and models continues to grow. Black holes have long been a topic of fascination and intense study, despite the formidable challenges they present to scientists. Research in this area is robust, marked by continuous discoveries and a growing understanding of black holes' complex and engaging properties. The theories developed span various aspects, from how black holes are formed to their significant influence on the surrounding universe. Each new insight brings us closer to a better understanding of these cosmic entities. A widely accepted theory about the origins of black holes centers on the collapse of large stars. As a star depletes its nuclear fuel, it loses the capacity to fight against its own gravitational pull, leading to its collapse. As the star shrinks, it becomes increasingly dense. If the star is large enough, this process continues until it shrinks down to a point of infinite density called a singularity, which marks the creation of a black hole. Researchers, including teams from NASA, are particularly focused on studying the centers of distant galaxies to learn more. For example, in the galaxy M87, astronomers have observed a huge vortex of extremely hot hydrogen gas spinning at incredibly high speeds, over 1.2 million miles per hour. Typically, such rapid movement would cause the gas to scatter outward, but this is not the case at the center of M87. The scientists deduced that only a supermassive object with a gravitational force powerful enough to counteract the outward forces could maintain the structure of this spinning gas disk. They calculated that this object has a mass billions of times that of the Sun, clearly indicating it is a supermassive black hole. But there's more to black holes than just being the result of star collapses and having a strong gravitational pull. Black holes are also believed to be critical in shaping the dynamics of galaxies. They may aid in the creation of new stars and influence the overall structure and evolution of galaxies. Additionally, some theories suggest that the rotation of black holes could twist space-time itself, leading to phenomena known as gravitational waves. These waves, which were predicted by Albert Einstein's theory of relativity, have been observed recently, providing strong evidence of the dynamic activities of black holes. Delving further into the theoretical implications, in 1963, mathematician Roy Kerr from New Zealand used Einstein's equations of gravity to propose a new model of a rotating black hole. Kerr suggested that a spinning black hole would form a fiery ring or a thin disk instead of collapsing into a singularity. This disk would spin so rapidly that the forces generated would prevent it from collapsing, resulting in what is known as the ergosphere, a region around the black hole where normal physical laws no longer apply consistently. Kerr's theory also raised the possibility of an Einstein-Rosen bridge, more commonly known as a wormhole. This theoretical construct is thought to be a shortcut through space-time, proposing that one might not be destroyed upon entering a black hole, but could travel through a tunnel and emerge from a white hole in another part of the universe, or even in a parallel universe. Understanding this concept requires a deep dive into Einstein's space-time theory, which describes space and time as interconnected, forming a four-dimensional fabric called space-time. Wormholes are a concept born from Albert Einstein's theory of relativity. Although they sound exciting, they have never been observed, and most scientists believe they would collapse too quickly to be of any use. These theoretical passageways, sometimes referred to as Einstein-Rosen bridges, suggest that black holes might serve dual purposes, not only sucking in matter, but also potentially acting as gateways to other regions of space or time. The idea of traveling through wormholes to explore different parts of the universe or even to visit the past has intrigued scientists for decades. However, using wormholes for travel remains purely hypothetical. The laws of physics as we understand them, especially the speed of light established by Einstein's theory of special relativity, prevent anything from moving that fast. The Kerr wormhole, named after the mathematician Roy Kerr, is one such concept. Kerr proposed a type of wormhole based on Einstein's equations. It's imagined as a tunnel that could connect far-flung corners of the universe, different universes, or even different times. Think of it like a doorway to another place, much like the magical mirrors in fairy tales. However, these wormholes, if they exist, could be fraught with dangers such as deadly radiation and unknown forces that could destroy anything that tries to pass through. This is why the theoretical stability of wormholes is a hot topic of debate among physicists. The inconsistencies between Einstein's theories and quantum mechanics, particularly concerning subatomic particles and radiation, underscore the need for a more comprehensive theory. This has led to the pursuit of a theory of everything. Such a theory would integrate all known physical phenomena into a single framework, helping us to better understand and predict the behavior of things like wormholes. The cosmos may hold hidden about the very nature of reality. The quest for superstring theory. Michio Kaku, a leading theoretical physicist, has dedicated much of his career to developing a comprehensive theory that ties together the entire universe's physical aspects. His goal is to unify the principles of quantum mechanics with those of general relativity, which could potentially open up new pathways in our understanding of space and time. The realm of physics, two towering theories stand: general relativity and quantum mechanics. They govern the universe but often contradict each other, creating a divide that scientists have long sought to bridge. Superstring theory emerges as a frontrunner among the numerous theories posited to unify them. This theory proposes an elegant idea. The smallest constituents of matter are not mere points, but tiny, oscillating strings. The nature of these oscillations determines the type of particles formed, analogous to how different vibrations on guitar strings produce various tones. Superstring theory weaves quantum mechanics and general relativity into a coherent whole, suggesting that these minuscule strings, as they move through space-time, could form the basis for phenomena like black holes and wormholes. However, it adds a twist to the conventional understanding of the universe by introducing the concept of 10 dimensions, 9 of space and 1 of time. This idea is hard to grasp since humans only experience 4 dimensions, 3 of space and 1 of time. These additional dimensions, according to the theory, are compacted to a scale so minute that they remain undetectable with current technology. To make such complex ideas more accessible, physicists often employ simple metaphors. One might consider fish in a flat pond, unaware of the concept of height, who only perceive the third dimension indirectly through the impact of raindrops causing ripples on their surface. Similarly, it is posited that humans might only detect these extra dimensions through indirect effects on observable phenomena. The depths of superstring theory. The strings are thought to vibrate not only within the dimensions we know, but also through additional, hidden ones. These vibrations influence the fundamental characteristics of particles, such as mass and charge. Intriguingly, the theory also offers a potential explanation for gravity, a fundamental force that has puzzled researchers for centuries. Yet proving the existence of these additional dimensions is daunting, akin to catching the wind with a net. Despite their theoretical elegance, these dimensions are so minuscule that they elude direct detection. Nevertheless, the scientific community remains hopeful. theorizing that unusual particle behaviors could one day reveal these hidden dimensions, which might be coiled up tightly, much like a scroll. Bill Nelson, the head of NASA, recently spoke with CNN about his views on UFO sightings. He expressed his doubts about dismissing these sightings as mere illusions. Although Nelson does not support the idea that these UFOs are alien spacecraft visiting Earth, he does admit that the consistent reports from Navy pilots and other eyewitnesses are compelling. Nelson acknowledged the uncertainty regarding the origin of these sightings, questioning whether they are from outer space, an unknown Earth-based source, or just optical tricks. Adding to the discussion, investigative journalist Michael Schellenberger has brought forward new information that has captured widespread attention in the United States. Schellenberger's research reveals that intelligence officials have identified approximately 30 aerial objects that they claim are not from this planet. This information aligns with statements from whistleblower David Grew, who has spoken about the U.S. government possessing several non-human vehicles. Schellenberger, known for his detailed investigative work, assures that his sources from the government's UFO study programs are credible. What stands out in Schellenberger's report is that those who provided information about the UFO crashes were either direct witnesses or had strong evidence to back their claims. Despite the significant revelations, this information is closely guarded and shared only with specific groups, including the All-Domain Anomaly Resolution Office. When Congress sought to verify David Grew's statements, they were told that verifiable information on the recovered UFOs was not available, which has led to speculation about whether the evidence is being withheld. What are your thoughts on these clandestine revelations? Do you believe the truth is being hidden? Like, comment and subscribe to join the discussion and explore the unknown together.